So Unit 3, Lesson 1, the trigonometric functions. So we're going to look at how you set up a trigonometric function and how they connect to each other. So what's very important is our little memory tool, which is Sohcahtoa. We should know what that means at this stage. Please ignore the students screaming outside. Okay, so if we look at the angle alpha, it's asking us to find sine of alpha. Sine is opposite over hypotenuse. So in relation to the angle alpha, opposite is the 8, and the hypotenuse is the big one, which is the 17. So it's going to be 8 over 17. Now if we look for cosine of alpha, that's going to be the adjacent, which is this one, over hypotenuse, which is 15 over 17. And tan of alpha is opposite over adjacent, which is 8 over 15. Now, it asks us to label the other angle in the triangle as beta. And what is the relationship between the angles alpha and beta? Well, here's the thing. Alpha plus beta must add up to 90. Because those two add up to 90, and then you add in the right angle, that's another 90, which gives you your 180. Okay, which means they are complementary. All right? So you need to note this down. Now, what you'll often see, when angles are complementary to each other, you would say that we have alpha is equal to 90 minus beta, and beta is equal to 90 minus alpha. Okay? So you need to note that. So for example, alpha, which is this one, and 90 minus alpha are complementary, because when you add them you get 90. And the same thing goes here for beta and 90 minus beta. They add up to 90, so they're complementary angles. So that's important, so note that down. Now, we're asked to find sine of beta. So sine of beta is the opposite, which is the 15 in this case. Do it in blue. Over the hypotenuse. Cosine of beta, now for beta, 8 is the adjacent. So it's 8 over 17. And then for tan, tan is the opposite. So what's opposite to the angle beta is the 15 over the adjacent, which is the 8. Okay? So, let's see, what connections do we notice between the cosine, sine and cosine of an angle and the sine and cosine of its complement? Well, look, here's what we notice. If you look at the sine of alpha and the cosine of beta, they're the same. So, and if you look at the sine of beta and the cosine of alpha, they're the same. So what we need to notice is that sine alpha equals cos beta, and cos beta equals sine alpha. So what I will want you to note down is that the sine of an angle equals the cosine of its complement, and the cosine of an angle equals the sine of its complement. So please write that down in your notebook. So like another way to note this down would be that sine alpha equals cosine of 90 minus alpha. And same way you could say that cosine of alpha equals sine of 90 minus alpha. So this is important, okay? Now, what do we notice about the relationship between the tan of an angle and the tan of its complement? Well, they're just the inverses of each other, or the reciprocals. So you can note down the tan of an angle. Tan of an angle is the reciprocal. So you take the tan of its complement and you flip it, is the reciprocal of the tan of its complement. Ignore that. Okay, let's move on. Trigonometric functions. So now, we're going to have a look at some problems related to this here. So let's see how we can play around with this whole thing. So these are basic problems. So it says, given the function value below, work out the other two function values for the given angle. So you have sine of 30. Basically, you want to work out what's cosine and tan of 30. Okay, so let's have a look at how we would do that. So let's see. So let's think of it like this. If you have a right triangle, and we'll say that this angle in here is 30 degrees. Okay, the sine is the opposite over the hypotenuse. So that means that the opposite, which is over here, must be 1, and the hypotenuse is 2. All right? So by using Pythagoras' theorem, we can find out what this side here is, and we'll call it x. So Pythagoras' theorem, using it, we'll get x squared plus 1 squared equals 2 squared, which is 4. All right? So that means that if you do the algebra on it, you're going to get that x equals the square root of 3. All right? So if x is the square root of 3, I'm just going to note that down here. Okay, from Pythagoras' theorem. Then, to get the cosine of 30, we'll do it up here. Cosine of 30 equals, well, for cosine of 30, you're going to do adjacent, which is root 3, over the hypotenuse, over 2. I'm just going to box that off. And also, down here we'll write down the tan. Now mine is a little bit disorganized because I'm running out of space, but try to keep it organized in your notebook. Tan of 30 is going to be opposite over adjacent, which is going to be 1 over root 3. Okay? So, if we look at the next one over here, part B, again we make our triangle, and don't worry that we don't have an angle number, that's not important. We're just going to say that this is the angle beta. Cosine is root 7 over 4, so that means the root 7 is the opposite, is the adjacent, and the 4 is the hypotenuse. So, working from that, you want to work out what this over here is. So you're going to have x squared plus root 7 squared equals 4 squared. So it's going to be x squared plus 7 equals 16. So x squared is 9, x works out to be 3, right? Now I raced through that, but we should be able to handle that algebra at this point. So this here is 3. And now, to work out the sine of beta, you do opposite over hypotenuse, which is 3 over 4. And to work out the tan of beta, it's opposite over adjacent, 3 over root 7. Okay, so we should be able to do that. Let's move down to the next couple of questions. Okay, so this one again, we have to work out the 3 trigonometric function values for its complementary angle. So this is tricky, okay? So this, we're given a value for the angle beta. Now we're going to look at the angle 90 minus beta. Okay? So what are we going to do? Well, let's make our right triangle. Like this. Let's put in our angle beta here. It doesn't matter where it is. Then we know that this one up here is 90 minus beta, right? This one I'm marking in red. 90 minus beta. So what we have is the adjacent to beta is 5, the hypotenuse is 6. Use Pythagoras' theorem to work out what this side x is over here. And then when you've got that, then we go and we look at the angle 90 minus beta, and we construct the ratios from that. Okay? And the same thing applies to questions B, says C and C. That should actually be a B here. B and C. So try and work through those and see how you get on. But it should be manageable, okay? Anybody who's not sure about them, we can work on them in class. All right? So good luck with that.